So today we're going to be looking at triangles, regular hexagons, and irregular polygons. And we're going to be looking at the same thing as on Tuesday, which was finding the areas. So let's remember triangles. So for triangles, we're going to look at specifically this kind of triangle. So as soon as I put this little 90-degree angle symbol, then we know we're looking at a right triangle. And so what's special about this? Let's consider this. Let's consider that we have the side 8, 15, and we want to find this side right here. Well, once it comes to a problem like this, as soon as I know it's a right triangle, then I can use my Pythagorean theorem. 8 squared plus b squared equals c squared. So what do I have? A squared plus 15 squared equals y squared. Remember, where a and b are the two shortest sides and c is the longest side. So what do we have? We have 64 plus 225 equals y squared. So we got 289 equals y squared. I want to get the y by itself, so take the square root of both sides so that cancels out. And so we have y is equal to 17. So now I know what the length of y is. Y is 17 units. Cool. And so we can find any of those sides by using the Pythagorean theorem. And more importantly, we can actually apply this to applications. So let's look at the first one. Okay, so let's see. A rectangular table measures 4 feet by 6 feet. Find the length of the diagonal brace placed beneath the tabletop. So let's see. So we have a table that is 4 feet by 6 feet. And we want to find the diagonal. So this is something that we saw before, and the diagonal is the line that connects one corner to another corner. So we're looking for this. So what do we have here? Well, we want to find x. So we got a squared plus b squared equals c squared. A squared and b squared are the two shorter sides. So that's 4 squared plus 6 squared equals x squared. We got 16 plus 36 equals x squared. So what do we have here now? We have 52 equals x squared. Take the square root, take the square root. So x is equal to, so this is equal to 7.2 feet. Cool. Okay, so let's look at this next example. So what is the distance between two centers of two pulleys if one is placed 9 inches to the left and 6 inches above the other? So what does that mean? So we have one of our pulleys like right here on the top. The other one we know it's somewhere over here. And we know that the distance between this one and the ground So we know the distance between this one and the ground is 6 inches, and they're 9 inches apart. And so we want to find what the distance is, or like how far are they from each other. So we can find this same way as before. A squared plus b squared equals c squared. We got 6 squared plus 9 squared equals c squared. We got 36 plus 81 equals c squared. We can solve this now. 117 equals c squared. Take the square root, and so c is equal to square root of 117. So we got 10.82 inches. Cool. Okay, so how do we find the area of a triangle? So let's look at this. Area of a triangle is always going to be this is the same thing as area is equal to 1/2 base times height. So, for example, let's say we have a triangle that looks like this. This is 10 inches, 10.6 inches. We have a height of 8 inches and 13 inches. So our area is equal to 1/2 the base times the height. So we got area is 1/2 times the base, which is 13, and the height, that is 8. So area is equal to 1/2 times 13 times 8, 104. So half of 104 is only going to give us 52 inches square. Cool. And so that's how we're able to find the area of a triangle. So I want you to notice a couple things though. When I'm looking at an area of a triangle, in order to use this formula, I need to have the base and I need to have the height. So what if I ask you to find the area of a triangle that only has this information? So what if I ask you to find that area of that triangle? Well, this, I can see that it has two sides that are similar. And so what does that mean? So if I ever want to find the area of an isosceles triangle, meaning that it has two sides that are the same, this is going to be my formula. Area equals 1/2 base times the square root of a square minus b over 2 square. So in this example, what do we have? Area is equal to 1/2, the base is 12, times what times the sides. Well, remember their sides are all the same, so 7 square minus 12 over 2 square. So what do we have? Area is equal to 12 times 1/2. That gives me 6. 7 square is 49 minus 6 divided by 2 is 6 square. So area is equal to 6 times the square root of 49 minus 36. So area is equal to 6 square root of 13, which when we do that on the calculator, we get about 21.63 feet square. Cool. So that's how we're able to find the area of an isosceles triangle, meaning where we have two sides that are the same. So what about the area of an equilateral triangle? Well, in this case, when we're referring to an equilateral triangle, we're referring to a triangle that has all the same sides. So all the sides are the same length, and so the area of that is a square times the square root of 3 over 4. which we can also just rewrite as 0.433 times a squared. So let's see this example. So looking at this example, what area of a sheet steel is needed to make a triangular pattern where each side is 3 feet long? So we have some steel, and we know that we have it in a pattern that is a triangle where each of the sides are 3 feet. So at this point we have an equilateral triangle, and we want to know what the area of this would be. So the area of this is 3 square times, so let's just use the better format, this format. So this is the one that I would recommend you use. So 0.433 times the side, which is 3 square. So area is equal to 0.333 times 9. And so this gives us area is equal to 3.9 feet square. And now we just found our area. Okay, so let's look at this example. So a window in the shape of an equilateral triangle was bordered by a wooden frame as shown in the figure. How many square inches of wood are in the frame? So we have the window right here, which is this middle part, and each side is 3 feet and 6 inches. On the outside we have each of the sides being 4 feet and 1 inches. So first we need to make sure that we can write them in the same kind of units. So what do we have? We got 4 feet plus 6 inches, which is the same thing as 4 times 12 plus 6, which gives us 48 plus 6. So we got 54 inches. Oops, sorry about that. Should have said 1 inch. So we actually got 49 inches. Alright, so now we know that each side on the outside is 49 inches. Each side on the inside is gonna be 42 inches. Cool, so now that we know each one, we can actually use our formula now and find the area of the inside, find the area on the outside, and subtract them. So, area of the outside. Area equals, because we know each of the sides is the same, so we're looking at an equilateral triangle. So 0.433 times 49 square, so area of the outside, gives us 1039.633 inches square. This is area of the outside. Area of the inside gives us 0.433 times 42 square. Area of the inside is going to be 763.812 inches square. Now that we have both of them, we can subtract them. So area of the outside minus area of the inside gives us 275.821 inches square. And that's what this part, that's what the wood side is. That's the area that it has. Cool. Okay, and so let's look at the area of a regular hexagon. And so with the area of a regular hexagon, we have a hexagon that looks like this, where we know that each side is the same length. And sorry for my picture, could have been a little bit better, but each of the sides is the same. And so we have area is equal to 3a squared times the square root of 3 divided by 2. And so let's look at an example. So let's say that we had a hexagon that was 4 inches. So let's say we're looking for the area of this. And so we're going to do the same thing. We're going to say area is equal to 2.598 times for square. So area is equal to 2.598 times 16. So area is equal to around 42 inches. Cool. And that is because we rounded it to the nearest whole number. Okay, so last thing. Okay, and so the last thing that we can do is we can find a couple of dimensions. And so let's see, the first one is going to be the diagonal. And that's what we said before, from one corner to the other corner. And we can find the diagonal. So from across corners, by using the formula, diagonal is equal to 2a. And we can also find the side if instead we're given the diagonal by doing a is equal to 0.5a. Oops. Meant to write d. Instead, besides finding a dos, we can also find the distance between each of the sides. Instead of going from corner to corner, we can go side to side. And we call this F because those are called flats. So this is from corner to corner. This is from side to side or flat to flat. And my formula is F is equal to 1.732 A. Or we can also find the side by using 0.577 times the flat, the distance between each of them. So distance from flat to flat, also known as side to side. Cool, so let's look at our last example. Okay, so let's see, for a piece of a hexagonal bar stock where A is equal to 1/2 inch, the distance across the corners would be, so oops, meant to write corners. So let's see, we have a hexagon and each of the sides is 1/2 inch. So we want to find the distance of the diagonals. We got 2a, so this is equal to 2 times 0.5. So each one would be from the distance from a corner to another corner is 1 inch. Now we want to find the distance. What about if it was from each side to each side? So from the flats, this is the same thing as F is equal to 1.732 times the side, which is 1/2. So this is equal to 8.66 inches. Cool. And that's everything for today.